All right, let's talk about complex numbers. Now remember, complex numbers are numbers that are both have a real component and an imaginary component. So we call complex numbers in standard form A, which is the real component plus their imaginary component, where B is just the coefficient of the imaginary component. So remember that when we're talking about absolute value of a complex number, we're really talking about the distance to that complex number. Okay, so for example, when we're graphing complex numbers, it really is as simple as graphing an x and y coordinate. What we're looking at here is the x-axis is now the real number axis, and the y-axis is the imaginary axis. So when I'm looking at a complex number, if this is the real component and this is the imaginary component, that's like saying its x value and its y value. So looking at this one here, if this real component is 3, I'm going to look on the real axis at 3, okay? That's that mark right there. And if I'm going to look at the imaginary axis as positive 4, I'm going to look on the imaginary at positive 4. And where they connect is right here. Okay, so that complex number imaginary, so again, we go over 3, up 4 in the imaginary direction, and this is my total value or absolute value of a complex number, okay? So when I'm talking about this, I can also name the point if I'm given the point. So looking here, I know along the real axis, we go down to -4. And in the imaginary axis, we're going down to -3. So we say this would be a value of -4 in the real minus 3 in the imaginary. So let's talk about how do we convert rectangular complex numbers to polar form. So remember, we're still talking about complex numbers. So this is very similar to looking at rectangular to polar before, where the radius is still x squared plus y squared. Now we're just talking about it in the complex field. And tangent is, or theta is inverse tangent of y over x, just like our polar coordinates from before. So if I'm looking here at this polar form, remember this is our real and this is our imaginary components. If I were to sketch this, our real component is -3 and our imaginary component is positive √7. So I don't know exactly where it is, but I know it's in that second quadrant. So let's look for the radius. So remember, we're going to go x, which is -3 squared plus, remember, even though this is an x, this is the imaginary component, which is its y value. So it's the root of 7 squared. So this becomes positive 9 plus 7, which is the root of 16. That reduces to 4. So there's our radius. And our theta, again, is inverse tan of y, which in this case is √7 over x, which is √3. Put that in your calculator, and remember, inverse tangent only gives you values from first to fourth. So if it gives me -0.723, remember that that's here. But because we know that our answer is actually got to be in that second quadrant because of where this point tells me, I know that I'm going to have to take from this fourth quadrant, I'm going to have to go all the way adding by pi to get to that second quadrant. So we're going to add pi to -7.23. In my calculator, we get approximately 2.418. Okay, so that's our theta. So to convert this to polar form, we're also going to say, okay, it's not just a coordinate. Okay, I'm going to put this next to it. I wrote too big. We have to say, hey, this polar form is going to be r cosine theta so r cosine theta, which was 2.418, plus the value of r sine theta times I, or we say r times I sine theta. Okay, you can also use a shortcut here because 4 is that common factor. So we could say r cosine 2.418 plus I times the sine of 2.418. Okay. All right, let's look at this one here. So again, we've got our real and imaginary component. So to find our radius, we're going to say 2 squared plus negative 1 squared. Because there's a negative 1 coefficient in front of I, we get the root of 5 as our radius. Theta is inverse tan of I, which is, or the y value, which is negative 1, over 2, which is x. And we get in our calculator negative 4.63. So double check again, where are we actually talking about? So if we're talking about this point here, 2 is in the positive x direction, negative I is in the fourth quadrant, it's down here. So we know we're talking about theta here, which is fine that they gave it to me in negative 4.63. So in order to state how to put this in polar form, remember we have to have our r, which is root 5 times cosine theta, 6.3, plus I times the sine of theta. Okay. All right, let's look at the next one. How do we convert polar complex numbers to rectangular complex numbers? So r is, again, x is r cosine theta, just like before, and y is r sine theta, like before. So now we're going to learn how do we recognize polar complex numbers. Well, remember, this is the r component, and here are our theta component. So looking at this, I know, hey, r is 3 and theta is pi over 3. So how do we turn that into a rectangular? Well, I know x is r times the cosine of theta, which is 3 times the cosine of pi over 3. Okay, so when I look at 3 cosine pi over 3, that's like saying 3 times cosine of pi over 3 is really 1/2. So we know that's really 3 over 2. And looking at y, we know that's r sine theta, and that's 3 times the sine of pi over 3, which is 3 times the root of 3 over 2, which simplifies to 3 root 3 over 2. So to write this in imaginary form, remember that if this is our x, that's our real component. And if this is our y, this is our imaginary component. So we put the imaginary component goes after our real coefficient in between the root. All right, and let's look at this one. We can also see and read through this that this is our radius here, where these are our theta. So we know that the radius is 4, whereas theta is 3 pi over 2. Let's convert this back to rectangular form. So we're going to get x equals r cosine theta, and in this case r is 4, cosine is 3 pi over 2. Remember, 3 pi over 2, if I sketch it, is right here. This point is 0, comma negative 1, which is cosine sine. So cosine is actually 0 here, and we get 0, so x is 0, and their y value is our sine theta, which in this case is 4 times the sine of 3 pi over 2, which we know here, sine of 3 pi over 2 is negative 1. So 4 times negative 1 is just negative 4. So if we're talking about this imaginary complex number, again, our real component is 0, and our imaginary component is negative 4i. So we get 0 minus negative 4i is our complex number. All right, I'll see you back in class.